Gamov from Confluence Kafka, talking around Kafka on Kubernetes.
I'm not jumping in the gym. I'm working out. All right, thanks. All right. So this is my favorite spot to talk, like either before beer or before lunch. So the people very invested to stay. So like if I will, make the people stay a little bit more, meaning that I'm doing a great job. Hi. Good morning. Parlez-vous français? Oui. Unfortunately, I'm not. I apologize for that. Yes, so my name is Victor. I'm coming to you from, also, I'm paying my bills in New Jersey, but essentially I'm everywhere in the world. Everywhere the people are struggling with the building stateful applications on the Kubernetes specifically, right? I'm a developer advocate at a company called Confluence. Confluence is a company that builds one of the distributions of Apache Kafka. We call it Confluence Platform, and we contribute to Apache Kafka project. Also, I'm speaking about all things Kafka, streaming, and today I'm going to be talking about some of the things about Kubernetes as well. You can find me in Twitter. How many of you have a Twitter here? It is very important. Nice. Okay, so for the people who don't have a Twitter, you probably missed very good stuff yesterday with Justin Bieber challenge Tom Cruise for a fist fight. I don't know if it's a good idea because like Tom Cruise is in a pretty good shape. We're working out together on the same gym with Archie. So like go like a three-way. So anyway, so it's very important. Like the Twitter stuff is very important because first of all, I'm building a very highly scalable hello world applications. I mean, this is what developer advocates do, right? Also, as my thank you that you're coming, I'm also running some raffle here, and that you can participate. Just tweeting about this presentation, just tweeting about slides, because I have a pretty awesome slides here, some fancy pictures, etc. All right. So, how much time do I have for this presentation, actually? Like 20 minutes. 20 minutes. All right. So let's do this. Let's see how we can do this. So I will do a very challenging thing. So I will try to show you some slides, also deploy some Kafka, also deploy some application, also deploy some monitoring stuff. And within 20 minutes, we will try to also extend the Kafka cluster and see if our applications still continue to work. All right. Kafka. How we end up here, right? So the organizations, they build everything around the data flows. You communicate to the people, you share information, the information flows through organization. But what we actually end up doing, we building some data stores, data silos. We start building applications, start small, we know all the modularization techniques, we know different languages, we have an ability to implement some modular things, and you start small, you start some microservices, you're integrating some in another application. In the parallel, some other components, some other the departments, they start building similar applications. They start building their own application to serve their needs, to serve business, so far and so on. And after that, you start communicating with applications. So, and how many of you seen this picture in your organization or some enterprise architect showed you? This is how it usually looks like. This is your enterprise architect trying to explain you your landscape, like data landscape, what is happening in your organization. So as the same old situation, you're not alone. So the big guys, like you want to be like big guys, Netflix, LinkedIn, stuff like that. Big guys actually been there and done that. So this is how the Kafka appeared. This is how Kafka came into play out of LinkedIn. They tried to solve a similar problem. And they end up doing is introducing so-called streaming platform or event streaming platform. When the data is not only in silos anymore, data is actually flowing. Different events going from one place to another. Some events might have just notification aspect. Some events might have some of the data. So it's not only notification, but also a state transfer. All right. So, and organizationally, people, how the people start doing with Kafka. So first thing what they do, they go into this kafka.apache.org, downloading shell scripts, downloading zip files, and they start running it. It's cool, right? So they start playing around this, they build cluster, they did this once in one place, did another in another place, another cluster, another server, so far and so on. Now, you want to run Kafka within an organization with hundreds of clusters. How we can do this? You're applying some automation. You know there's some awesome tools like Chef, Puppet, Ansible, and so far and so on. You start automating things. You know how to provision this the cloud machines, and on these cloud machines you're preparing for an environment. Kafka runs on Java, you need to install Java. After that you need to perform installation of some additional components like Zookeeper. You're also preparing this. After that you install Kafka, so far and so on. So far so good. Now, from the previous presenter we learned that some of the company thinks that to reduce the cloud bills, they actually need maybe implement something different from the cloud. Right, so they start thinking, okay, so I'm running this the virtual machines. I heard this thing Docker allows me to more use this infrastructure more efficiently. So I'm start building these Docker images, and this is the way to go. So you start putting stuff inside the Docker, and now again, still the challenge. You need to run hundreds, maybe thousands Kafka nodes. How we can do this? You learn there's a thing called Kubernetes. And this is where we are. This is the Homo erectus Kubernetes type of thing, right? So we now we stand tall, and the Kubernetes is the thing. All right. However, also we learned that from the previous presenter, the replacing one thing that tries to replace your cloud bills with another thing, maybe not that wise of a choice, right? And obviously Kubernetes has names from the different Greek or mythology, so this particular case is the god who wants to spend your money on cloud bills. Alright, so we heard that some people are running here, and I think this is my favorite audience because I don't need to convince that like this is the thing, the Kubernetes is the thing. I have two questions, essentially, four essentially. It's two parts of the question. The first question is, how many of you are running stateless workloads on Kubernetes? All right, good. How many of you think it's a good idea? Just need to keep hands. Okay, all right, cool. How many of you are running stateful workloads on Kubernetes today? How many of you would think it's a good idea? All right, so not so many. All right, so the challenges, there are a lot of challenges with this, right? So we need to deal not only with infrastructure, but also we need to have internal ability, we need to have an internal knowledge about the framework. We need to know what kind of application we're running there. Because there are some building blocks that are available there, but not every building block's able to fulfill every possible requirement for any possible application. All right, how many of you heard about Kelsey Hightower? All right. How many of you heard about Ben Shapiro? If you're in the Kafka world, this is Kelsey Hightower of Kafka world. All right, so opinions, right? So Kelsey very famously tweeted about that to run. He probably already hates that he tweeted about this because everyone trying to remind him to tweet. But he actually has some pretty good idea here, is that the Kubernetes can only meet these stateful workloads halfway, meaning that there are some available building blocks that help you to build stuff, right? But not every distributed system, not every stateful application created equal. So that's why that requires some little bit knowledge. So, and running the stateful applications on Kubernetes is tricky, right? How many of you got the reference from the Archie's t-shirt? It's tricky, right? Running Kubernetes, it's tricky. Run DMC fans? Run DMC? All right, cool. So, there are some things that you can do around storage, some things that you need to know about storage, some things you need to know about networks, some things you need to know about security, so far and so on. Lots of interesting things, specifically security. You see, security is so important that I always put it this last. How many of you are putting security in the first? All right, cool. My people here. All right, cool. But still, Victor, we want to just run the Kafka, right? So how difficult would it be? And how we will deploy this? Probably we need to grab some of the Helm charts. Helms just allows us to get this templates. We apply some of the values there, and we're good to go. So we'll do this. I also explained this in the video. If you're interested, me drawing on the imaginary whiteboard. Feel free to check this out. But essentially, how Helm will help with the complex logic. You know, every time you need to think yourself, every time when I'm putting some shell scripts inside my YAML file, am I doing this right? Am I like maybe there's some kiddings died somewhere when I'm putting this the sh files inside my YAML file, because YAML is inherently declarative language, and you're trying to put like the Turing complete language. I can say Bash is more or less inside your declarative template somehow. Not super cool. And why is that? Because there's some complex steps needs to be performed, right? Some of the things that you need to do in order to this to happen. So, for example, in Kafka world, in order to perform a rolling restart in case we want to do scale up or we want to do upgrade, we need to do certain steps. This is normal stuff, and every Kafka SRE knows that. Like, you need to stop one of the broker when wait until you will have under-replicated partitions will go down. If you don't know what's under-replicated partitions, it's okay. You don't have to know, but this is very important. This is an indicator that your replication successfully done and your data is safe, because you wouldn't want to lose the data. Now, all these partition reassignments, leader reassignments happen. Next steps, we need to wait. Like if we bring in something new. Also, there's one important step here. We don't want to kill arbitrary broker, because one of the brokers is a controller. Controller has a little more responsibility, and the time to bring controller up requires a little bit more, and so far and so on. So it is not trivial logic, and like you can actually perform this in your YAML and your shell scripts. It is doable, it is possible. I'm not saying this is impossible, but we want to run this in scale, we want to run this in an organization. We just don't want to worry about this, right? So in this case, it requires something. And depends on the size of the cluster. This operation can take up to from minutes to days. So, because like you need to wait, there's a lot of things that you need to figure out, check, and things like that. But yeah, you can say the Kubernetes has certain things that allows you to perform this, like certain order. But again, it is not important, because your SRE, your Kafka DevOps, Dev Kafka Ops person will tell you it is not something that you want to do. All right, let's take a look what we're doing here. I can deploy Kafka all day long, but it would be not super interesting. I want to actually show some of the apps and show you how the Kafka helping us to building apps. I probably will try to use different microphone. Is this on? All right, good. I will try to, I think I'll just simply do this, because this stuff is not very convenient. Now if you want the same level, my microphone is here, and I'm driving. So this is my small app that allows me to drive from place to another, one place to another. So there's a rider component, there's a driver component, and I will show you how I can do this. But before, let me deploy some Kafka. So what is cloud native? So in the Kubernetes world, we want to have a software that will be understood by same tools. You don't want to change your tool sets every time you're introducing a new thing. You bring in new database, you bring in Kafka, you bring in something else here. And ideally, you want to talk to this tool the same way as you're talking to other tools. So in this case, integration with the Kube control is must. One of the things how we can extend this is the custom resource definitions, right? So you define custom resources, and with custom resources, you defining your database, your Kafka, and in this particular case, we also have some interesting resources. Now, for example, Kafka cluster. So I want to teach Kube control to understand Kafka cluster the same way how Kube control understands your persistent volume, or your service, or something else. In this case, my Dev Kafka Ops person will be focusing on actual things, deploying Kafka cluster. He knows how many nodes, what's the replication factor, so far and so on. So also, Kafka has dependencies. So now imagine, we're running complex distributed system that depends in another complex distributed system. Both these systems depend on some state. Zookeeper is a database, Kafka is a database. They need to connect through the network. Also, they run on top of distributed system, which is Kubernetes, that runs on top of a hardware, which we don't know is actual hardware or it's a virtual hardware. So the level of complexity is really high. So that's why you have a lot of things, a lot of places where you can fail. While I'm talking, I'm deploying Zookeeper because Zookeeper is a prerequisite. And I'm using Helm here to deploy all these things. But the important thing, Helm is also suitable not only deploying standard Kubernetes things like persistent volume, services, and so on, but also you can deploy anything because Helm is just a templating engine. How many of you are excited about Helm 3? All right, so I think you're excited about Lua specifically, maybe? No? Yeah, this is what I thought, because like you don't want to have this conversation with your parents, like on the Thanksgiving or any other gathering when you have a all family here, your mother's friend's son, and she always thinks that he's more successful than you, and she's asking you like, what kind of language you programming? And he was like, Lua. No one wants to have that, right? Everyone's saying, okay, it's a Scala, it's Go, it's a something like cool, like maybe Kotlin. I'm programming Kotlin here, so I want to sound cool. So what is happening here right now? So my requests from my laptop go into my cloud. Inside my cloud, I'm performing deployment. And to see if there's actually something happens, very useful command that's called Zookeeper Control get pods. So, and I have these pods with Zookeeper. This is pods with my operator that listens to something like this. So the way how this custom resource looks like is like this. That's it. This is the only thing that I need to know from perspective to deploy Zookeeper. Or not necessarily know, but from perspective of I care. I need to know how many nodes, I need to know how much memory I need to put this, and I don't really care about the rest. And the operator, what it does is it goes here to services, for example. Establish network with the Zookeeper, so Kafka will be able to discover the Zookeeper. We can do persistent volume claims. And we're getting all this disk history figured out. One of the global configurations that I have here is, don't look here because it's a password, super secure, is where I'm deploying this stuff. And it makes sense to have disks in the same place where you deploy your software. So that's why I'm specifying my zones. I'm running this in Europe. So far and so on. So far so good. Now, I said I want to use a full capacity of Zookeeper Control. So in this case, I can use Zookeeper Control to get status. For example, Zookeeper. In this case, I want to see how my Zookeeper looks like. And as you can see here, this is my custom resource definition called Zookeeper cluster. A lot of cool stuff here, specifically image, JVM config, and status. This is the most important thing that I always know with the standard tools, and I can teach the standard tools to understand this non-standard thing, non-standard database, right? Now, we have Zookeeper, it's running. So now we can add here, 5 fingers. So we're deploying Kafka next. So in this case, I'm not specifying anything about Zookeeper here with Kafka. When this is fine, what the name, in this case it will create default services and connection string, and it will be using some rules to discover the Zookeeper, and will connect to the Zookeeper. Now, with this configuration, I also can enable external access, which is not so trivial to do in general, but operator knows how to do this. When I say external yes, it will go and work with the external DNS, with Cloud DNS, and provision correct endpoints, connect things around, and everything would be so good. Now, it's continue to deploying things, let's take a look how my actual Helm chart look like. So for this particular case, I'm going chart and say Kafka. And where's my CRD? Kafka CRD looks like this. Lots of YAML, right? So lots of the code templating type of things, a lot of things that you can do, lots of places where you can put some defaults. For example, you deploy in Kafka, and after that you want to have, like, everyone will get his own Kafka with 5 nodes. So you can go there and just provide these defaults, and everyone will be deployed with 5 nodes. Now, what is going on here from perspective of pods? We start in Kafka cluster, and the deployment script also checks, like, if it's ready to receive traffic, if it's ready to serve our application. It's almost ready. So, cool. Now let's deploy my application first. So my application is super simple. In this particular case, I just show you deployment. It's just the Spring Boot applications. Spring Boot, anyone? All right, cool. Some people. Spring Boot is just a Java framework that allows to build microservices. Again, super secret passwords to accessing Kafka cluster. But cool thing is that the only thing that I need to specify here is this. And how I can get this information? I can get this information from Kafka resource. In this particular case, I know cluster is running, and this is the configuration that my clients can retrieve. So this client also can use auto discovery to connect to the cluster. So in this particular case, let's see if my application is up and running. I'm using super useful command, port forward, because I don't have DNS configured here. All right. We start with one app, and we start with another app, because there's no place like localhost, right? All right. So up and running. 2 applications are running. They connected to Kafka. Let's see if we were able to do something with this. Google Chrome is a piece of software that cannot obey the rules of macOS. So this is why standard tools that work for other tools like Safari don't work with Google Chrome. Anyway, so this is where we are. This is our location, right? So this is where our driver starts. And our writer wants to go here. Okay, so our driver will be able to see our writer, and it clicks go and come to pick up. Now, from this moment, these two screens are synchronized through Kafka that runs inside my Kubernetes cluster, and everything that happens on the screen is pretty much in real time. So we will keep this for a while. It will take them maybe 5-10 minutes to reach this point. Now, I mentioned monitoring. So let's do something with the, oops. Again, fat fingers, always hard to type when you're on the stage and hundreds of people are looking at you and support you with your attention. Now, as you can see, application is still working. The car is riding thing, and the reason why I would want to show you this the monitoring tool. I will get back to this in a moment, so give it some time. So essentially, when I said everyone showing you support, I expected something like this, like wild reaction. Okay, I deployed on the stage, standing on my knees, and remember, like I've been in the gym yesterday, so like I'm sore AF. Thank you. Security concern always goes at the very end. Security is very important. The operator has built-in capabilities to support any type of enterprise security that Kafka provides, and the operator does it with a very precision and performance and things like that. So you don't need to worry about like provisioning your keys. There is some ways of how you deploy this, and the operator will be integrated with like secrets in Kubernetes, so it works. And automatically provides configuration. You saw these like endpoints where I connect things. It is cool stuff. Now monitoring. Let me see if my what is still coming up, and it's coming up because like everything is a cloud. Everyone the cloud it runs somewhere. It's cool, but no one said it's going to be fast, right? Still waiting for some of the monitoring. So Why it's important to monitor tool? Because again, you have so much landscape to failure because you have running, again, distributed system that depends on another distributed system that runs on top of distributed infrastructure, maybe distributed disk, all over a network. If you extremely resilient or disaster recovery focused, that you might be running across multiple AZs and so far and so on. All right, so we're running here. And another very enterprise-friendly command, control center. So one thing what I want to show how you would scale this kind of cluster, right? So we have this number of nodes here. Come on. All right, so 3 brokers. Another thing that there's 2 topics that these two applications communicate. As you can see, my car is still going, so I can go here and inspect this topic and see if data is actually flowing. I have some information about coordinates, I have some information about driver ID, latitude, longitude, and what kind of rider it comes to pick up. So I can also see data that come into the system. The next thing is that, let's see how I can scale this cluster without breaking it up, right? Ideally. But we'll see. So this is how you do it essentially in the real world, right? You just go there and edit your custom resource with the editor of your choice, and this is how you kind of like deploy things, right? I'm just kidding. You don't do this. It's, you need to go through the change control, and obviously you know that if you're extending this, you probably need to pay more because you have more nodes. But hey, YOLO, right? So let's do this on the stage because like for likes, for retweets, for all these things what we do on the stage. Now, save it, quit, and let's see. So what is happening, operator detect change. It goes there, it says, okay, I see that someone changed replication factor, now I'm go ahead and start doing things. So it create a container, we will see how it goes here. We'll keep it for a while here. Last but not least, yeah. So can we do something more complex? So one of the things that I demonstrated last time, in the same position, not standing on the knees, but like on the stage, is how we can do multi-cluster, multi-cloud deployments using the same tools, again, within like 25 minutes. And how we can go from, say, from one cloud provider to another. Maybe there's bill would be lower, and so far and so on. This kind of configuration that I envision, so you can move easily from one platform, from one cloud, from one place to another. So this is basic our mission at Confluence that allows you to run your streaming platform everywhere you want. And if you want to go from one place to another, you can easily do with our tools. Again, this is my video where I'm talking more about security aspect of Kafka, external access, integration with the cloud DNS, this kind of thing. So Kafka Summit. Anyone heard about Kafka Summit before? All right, cool, yeah. Anyway, so the operator will be released in a couple weeks. Give it a try. You can always go to the Slack. This is a community where we gather not only from people from internet, but also our engineers are hang out there and answering the questions. Always, I trying to look up to this Kubernetes channel in the Confluent community. Again, thank you so much for your time. You can always find me on Twitter, and you can always email me if you have any questions about Kafka streaming, Kubernetes, and so far and so on. And thank you so much for your time.